Hello, let's continue our Sudoku adventure with Killers in the Fog by Randall. This is continuing our killer cage theme week, so I hope you're enjoying that. This is the second puzzle of the week. And so we have killer cage constraint along with fog. So I know fog is a favorite. Let's go over the rules. We do have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have killer cages in the grid. You can't see any completed ones right now, but let's say this was one, these two cells. You would see it completely surrounded by dotted lines. So the fact that this cell is not completely surrounded tells us that the killer cage does continue down into this cell, right? Because you don't see the border inside. But anyway, digits surrounded by these dotted lines, those are cages. So the digits in a cage sum to the value in the top left corner. Additionally, what am I saying? Additionally, digits don't repeat in cages. So if, say, this was one complete cage here, let's say these three cells were a cage. This, I'm going to do little digits so we don't actually reveal the fog. If this was a 2, this could not also be a 2. Can't repeat in the cage. If they're the same cage. Additionally, just something to know is that you can use this for your logic, and sometimes you're forced to in fog puzzles. The clue for the cage is always the leftmost cell of the topmost row. So you look for the topmost row first. So for example, let's say this was a cage that made purple. In fact, I don't even need to do that. I can use the pen tool. So let's say this was a cage here. Then we would look at the top row of the cage. This is the top row of the cage. And then the leftmost cell of that top row. And that must contain the clue. And you can see it does. Which means we could not actually, ignore this boundary here. We couldn't draw the cage like this because we know that this clue, the clue would have to be here instead. Or you couldn't draw the cage, for example, here's a good example. The cage couldn't be like this because the top row is here now, and the clue would be in the leftmost cell of the top row, which would be this cell here. So you can use that logic. Let's see, does it say that all of the cages, it says the cages don't overlap. So that's good to know. If a cell's in a cage, it's in one cage only. It doesn't say that the top left value can be omitted. So for example, we know that there is going to be a clue attached to this cage. And then additionally, we do have fog. So I probably should explain the fog first. But some cells are gray in the grid. And they're only temporarily gray. Once you get a correct digit, let's say you got this digit correct, it would reveal what's behind the fog in that cell and all of the 8 surrounding cells. So in total, you can get up to 9 cells revealed for getting a correct digit. The point of this is to reveal as you solve the puzzle. It is not to guess and check. If you're guessing and checking using the fog, I mean, it'll work, but that's not the point of the puzzle. You might as well not do the puzzle if you're planning to do that. It's a waste of time. So don't just try 1 through 6 in this cell and go, oh, it's a 5 because 5 revealed. You could, but let's not do that. All right. There is a logical path through without guessing. So those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right. So I know a 4 cage, and we know it takes at least 2 cells because this cage doesn't finish. 4 cage has to be 1, 3. Watch my video yesterday if you want some tips on domino cells and their sums, and in general minimum and maximum sums. 3 is going to be 1, 2, and we can actually draw these cages. So I'm actually going to use what color should I use? I'll use a green color here just to avoid having it interfere with our normal box borders. So we know those are cages. But with this 1, 2 pair here sees this cell, meaning it can't be a 1. So this is a 3 and that's our 1, and it did reveal, so we know we're correct. Once I've revealed a cage entirely, I'm just going to remove the pen tool from it. All right, so this is 12 and 3. This 8 comes down to at least here. So we know at least this comes down here. You know what I can do? I can just draw that, and that'll tell us that takes that. We know this takes, we know this takes this cell. We know this takes this cell, and this takes this cell. So this has to be at least a 3-cell 9. Now, we actually know that it is a 3-cell 9 because you cannot do 9 in 4 cells because we can't repeat digits in cages. So the minimum we could do is 1, 2, 3, 4, and that's 10. So 9 is the biggest 3-cell cage. And we know this has to be 3-cell cage because this cage doesn't have a top border, so it uses this cell. And so does this cage has to use this cell as well because it doesn't have a right border. And so there's a few ways to make 9 and 3 though. There's 1, 2, 6, 1, 3, 5, and 2, 3, 4. But we know this cell's not 1, 2, or 3. So there is one property. This is actually a really useful property of 3-cell 9 cages, which is that you're going to have 2 digits that are from the 1, 2, 3 range and 1 digit from the 4, 5, 6 range. Here's a nice way to prove that. So if we had 3 digits from the 1, 2, 3 range, we would be 6 because we'd have 1, 2, and 3. That's too small. If we had 2 digits from the 4, 5, 6 range, 4 plus 5 is already 9, so we'd be minimum 10. So as a result, we know there's 1 digit from the 4, 5, 6 range, and it's this one because this sees 1, 2, and 3. These 2 cells actually see a 1, which if I had noticed there couldn't be a 1 in here, I would have just immediately said it was 2, 3, 4. But we can work through this, right? Because we now know that this has to be a 2, 3 pair because we need 2 digits from 1, 2, 3, and 1 is gone from these 2 and from this one. And now that's 2 plus 3 is 5. This one has to be a 4. All right. This is a 5, 6 pair. We know this 9 takes here, and now we know this 9 is done as well. These both see 1, 2. So only one of these 2 cells can be a 3, and it can be in the 1, 2, 3 range at all. So we know that one of these is a 3, and one of them is from 5, 6. See what I mean? And we know that this is from 1, 2. Because we need 2 cells from 1, 2, 3 in a 9 cage. We know it doesn't grow because 3 is our max for 9. We know there's going to be 2 from 1, 2, 3. And we can only put 1 of 1, 2, 3 in these 2 cells because of the 1, 2 pair. In fact, this is just a 3, 5, 6, right? And then this cell here then has to be the overflow. That has to be from 1, 2, 3, and it can't be 3. And then we know the other one's from 4, 5, 6, but 4 is gone, so we need a 5, 6. There's an easier way to see this though, which is for the box. And then you could resolve it from here, but let's just do it a little bit easier. In this box, we knew that this had to be 3, 5, 6. This can't be 5, 6. That already adds to 11. Also, it's 2 from 4, 5, 6, if you want to think about it that way. So this has to be a 5, 6. It does put a 3 in this cage. Now, we can't do 3 plus 6. That's already 9. So we're going to do 3 plus 5, and then we need a 1. And that 3 plus 5 puts the 6 here. I just want to show a lot of different ways to think about these cages because I think they're very useful things to use in your killer cage journey. All right. I feel like it's kind of the point of me showing these solves. All right, this is a 2, 4 pair. This could be 8 and 2. If it was, it would be 2, 6. We couldn't use the 4, but it could also grow. It could grow down. It can't grow right anymore because it's been revealed and it doesn't. 14. You can't do 14 and 2. So we actually know how this 14 cage works because of the top left rule. Right, and I'm sure there's other stuff we can do, but I saw this, so I thought I'd explain it. So we know this goes down into here, and I could go left actually, but we know it doesn't grow into this row. Now 2 cells add to 11 max, but we could do it in 3 cells, and we could actually curve left because the top row is all we care about for cluing. All right, so we don't know how that goes actually. I misspoke. Okay, we can sum this column to see how the 8 cage might react. Because we know that the 8 cage is either 2 cells or 3 cells. But I'm going to tell you it can't be 3 cells. Because if it took these 3 cells, then that would mean that the sum of this column would be 12 plus 8. Because these 3 sum to 8, these 3 sum to 12. 12 plus 8 is 20. But we know that the column has 1 through 6 in it, which sums to 21. So that would be too small. We would not be able to do both of those sums. As a result, that means that it doesn't grow down. So we know that there's this border here. We know there's this border here. And then we know that there's a border here because there's no cage in this cell. So it has to go like that. Can't do 4 plus 4, so we're doing 2 plus 6. That's 4, that's 5, that's 6. All right. Now, we need a 1 in this column. This 1 says not here, so that's our 1. We knew the 1 would be the odd one out as well because, again, 12 plus 8 is 20. So these cages cannot contain a 1. Because the 1 needs to be the thing that's not in the cages in order to sum to 21 in total. These 2 cells are 3 and 4, and 3, 4, 5 does add to 12. Another neat little quick math, like mental math trick, is if you have 3 consecutive numbers, just triple the middle number, and that's the sum. So 1, 2, 3, triple the 2, that's 6. 2, 3, 4, triple the 3, that's 9. 3, 4, 5, triple the 4, that's 12, right? Because you can think about taking one from the big number and giving it to the small number. And now you have 3 of the same digit, which is the middle number. All right. This is 2, 5, 6. This 6 isn't here, so the 6 goes right there. This is a pair. It's 2, not 2, 4, 2, 5. So that means this is a pair for the box. We need a 3, 4, which means this is a pair for the box and the column. We need 2, 5. We know 12 has to grow, so it's got to grow here because that's the only place it can go. We know this isn't in a cage. Now, 12 and 3 is absolutely possible, but so is 12 and 4. So I'm not sure what to do with that yet. There may be some simple Sudoku to do here. Is it this 14 cage yet? I'm not sure. We know one of these two is a 6. 6 is good for 14, though. I don't need this line here. All right, what's our next step here? We know that 4 ends up in here somewhere. The 6 goes here. There we go. So that revealed that this 12 cage actually takes the entire row. And that placed the 6 here. And so this did wrap to the right. So if I had accidentally made it wrap to the right, I would have been unfortunately correct. Lucky mistake. Anyway, it did not make the lucky mistake. That's fine. These two add to 8. 14 minus 6 is 8. So we can't do 1, 7. We can't do 2, 6 because 6 is already in the cage. So we have to do 3, 5. Can't do 4 plus 4. That repeats the 4. And so now 4 ends up over here. Let's just, we need 1, 2, 4. It's not a 1. Okay, so we know what this digit is. And the easiest way to do that is we know these add to 12. This cage continues, right? So these add to 12, and then this is 6. 12 plus 6 is 18. How do we get from 18 to 21? That's with a 3. So that's our 3. That's a 4. We DT2 it in the corner. Let me show you another little quick mental math trick here. If you don't want to do like if you were trying to go fast and you don't want to do the addition, think about parity. So we know that the row adds to an odd number. Of course, when I explain it, it's going to take longer, but if you just naturally internalize the rows, columns, boxes, they add to odd numbers. This is even, this is even. An even plus an even is still even. So this number has to be odd to get us to an odd number, specifically 21, but the only odd number available is the 3. So that is going to be the 3, and that's a nice little shortcut. Okay, 3, 5 pair here gives us the 2 and the 3 here. That's our 1 and 2. That's our 4, 1 and 2. We get our 3 and 4, 5 and 2. That's 5 and 2. That's 3 and 5. That's 5 and 3. These 3 digits are 1, 4, 5. So the 1 goes here, the 4 goes there, the 5 goes there. All right. Nice and clean puzzle, Randall. A lot of opportunities for me to explain some neat concepts, so I'm glad I had that opportunity. I don't think we had to use the top left clue rule at all. It kind of went smoothly without using that. I thought I could use it for the 14, but I couldn't. We did know the 9, maybe? I think we might have used that for the... I don't think we had to, though. But we definitely used that 9 cages max out at 3 digits. And I really like that sort of mental model, like these mental models you build up to try to, like, instead of case checking, to sort of internalize certain features of very common cages. The 3-cell 9 cage is extraordinarily common in killer Sudoku. And so internalizing that you need 2 of 1, 2, 3 and 1 of 4, 5, 6 can really help you speed through some of these things and sort of shortcut some of the logic and not have to case check everything. Things like a 3-cell 8 cage need a 1, for example, is also useful. Things like the rows, columns, boxes add to an odd number in a 6x6. Make sure you're careful about the size of your grid, because every other one adds to an even number. But in the common 6x6, is it every other one? Well, 6x6 and 9x9 are both odd, because 6x6 is 21 and 9x9 is 45. Which is weird. I would think it would be every other, but no, it's not. It's a bit more complicated than that. Anyway, cool. Well, I enjoyed this, Randall. Let me know how you did. And if you enjoyed it, why not leave a like, subscribe, and a kind comment below.